Hi, you're watching 365 Data Science Use Cases, a great initiative to highlight excellent use cases for data across all different industries. Hi, I'm Jen. Today I'm going to be sharing one of my favorite data science use cases. I've worked in analytics for 15 years and currently run my own analytics agency, as well as teaching other people about analytics and how to get into analytics jobs. Check out my channel, The Career Force, which you'll find up in the right corner or down in the description of this video. There are so many great use cases for data. One of my personal favorites is predictive vehicle maintenance. A lot of people don't realize just how much current vehicles are driven by software and driven by data. And I'm not talking about just electric vehicles or self-driving vehicles. Just the typical vehicle on the road that's been made even in the last 10 years has hundreds of thousands of lines of code behind the scenes that are helping power it, control its emissions, and monitor what's happening with the vehicle for safety, emissions, and multiple other reasons. When it comes to commercial vehicles that are transporting all of our goods behind the scenes, think those tractor trailers you might see on the highway, a vehicle having a problem is a much bigger deal than if your car won't start in the morning. That might be inconvenient for you, but a commercial vehicle, a tractor or trailer that is broken down, won't be able to deliver things. They might hold up multiple stages of the delivery process. And we saw some of this when we had breakdowns earlier this year when stores couldn't get supplies and many places were out of stock. There were production issues, but there were also delivery issues and getting things moved quickly enough to the right places. For many years, on both the consumer and the commercial level, vehicles have come equipped with some sort of telematic systems. Telematic systems are vehicle tracking devices that allow us to read, store, and communicate telemetry data. These telematic systems capture information like location, speed, fuel consumption, and they also capture information about all the sensors on the vehicle and what sort of readings they're having, if there is any sort of fault with a sensor, and specifically what the fault or the issue is. In the past, this information was really treated as a retroactive supporting diagnostic tool in a vehicle. And specifically, let's talk about commercial vehicles. So in the past, let's say 10 years ago, if a truck was having an issue, a tractor was having an issue, they would go into their local dealership or a dealership that's nearby where they are. They would wait in line. Sometimes they'd wait multiple days to be seen. There would be diagnostics, which could take many hours if there's a complicated issue. And the telemetry data was a supporting factor. It was one of the clues that were used to help diagnose what was happening. Then once that diagnostic was made, the repair could be identified and the truck could be fixed and back on its way. Or it could be identified and then parts need to be shipped because the dealership doesn't have them in stock. They need to wait longer, and maybe a week or two later the truck is fixed. Maybe this doesn't seem like that big of a deal when you're talking about a big fleet of trucks. Maybe somebody like FedEx who has tens of thousands of vehicles operating at any time. But it's also a very carefully orchestrated process to make sure that every vehicle is in use as much as it can be, and things are organized in a way that the time frames flow well, everything gets delivered on time. And many trucks are also operated by small fleets. They might have a dozen trucks or less, or individual owner operators where they have one vehicle and that one vehicle is their entire livelihood. So not being able to do your job, not have any money coming in for 2 weeks because there's an issue is a massive problem. This doesn't have to be entirely reactive though, and this is where that data use case really starts to be impactful. Instead of just focusing on what's happened in the past as a way to support a repair right now, we can read this information remotely off of the vehicle. We can see what different issues there are, what fault codes there are, if the vehicle has been running in conditions that may be creating an issue, where there's a high engine speed or a high load on the vehicle that can typically point to earlier failure of a part than what a typical usage would suggest should happen. By combining all of this remotely read telematics data along with other data we have about what vehicles have experienced issues and how we've repaired them in the past, we can actually start predicting what's going to happen and get ahead of it. So that instead of the inconvenience of being broken down on the side of the road, instead someone is able to contact the driver, contact the company and say, you're having an issue, you have a little bit of time, but we want to get you scheduled to get this fixed. We use machine learning to be able to do this prediction. What factors typically lead up to a specific type of failure, and primarily focused on failures that leave the truck inoperable, that it can't work or it won't run at an acceptable speed until it gets repaired. Then we can take that information, and here's almost an entirely separate data use case in itself. We can look at all of the dealerships in the area that the vehicle is or is traveling to. We can look at their stock of different parts and identify how busy they are, so that not only is the driver contacted and told you have this issue that needs to get fixed, but they proactively know what the issue is. They're given an appointment at a dealership along the way that is available to look at that truck right away, and they make sure that that dealership has the parts necessary to do the work. So a repair that in the past could have taken several days if the part wasn't in stock and the diagnostics were difficult, now can be done in the matter of a few hours. That's still inconvenient, but it's a massive shift forward, and it's a much less inconvenient problem than in the past. Predictive vehicle maintenance isn't just convenient, it can really save millions of dollars, especially for larger companies, over even relatively short time periods. And even one truck with one problem can cost thousands of dollars beyond the actual repair cost, because most companies have delivery timeframe agreements in place, where if the delivery window is missed, there are penalties to pay. With data, these problems can be largely avoided and anticipated and really make the process smoother for everyone. Thanks for sticking around to the end of this video. Be sure to check out my channel for more analytics insights and analytics career help. And please subscribe to 365 Data Science to get more great use cases like this